Welcome to a lesson with Dr. Powell. We're going to talk about converting between conjunctive and disjunctive normal form of a Boolean algebraic expression. Now, a Boolean algebraic expression is made up of variables, which it can take on the values of 1 and 0, and symbols. This means this is like a logical and, or also sometimes called a meet. It's also made up of, it could also be made up of symbols like this. This is a logical or, sometimes called a join. Okay, so let's suppose that we have something like A and B, or A and C, or not B. Okay, so this right here is written in this is written in disjunctive normal form. Disjunctive, you can think of a disjunction if you want to as kind of like an or. And what's being ored together? Well, things with ands only. And so things with ands here. So it's kind of like there's and things happening and there's or things in between. That's called disjunctive normal form. Conjunctive normal form is something where it's the opposite. You have ors and then you have ands and ors and ands and so forth. That would be conjunctive normal form. So, and the top right here, at the top, we have disjunctive normal form. So, how would we change this disjunctive normal form into a conjunctive normal form? We can do this in a couple different ways. One way, maybe first, is we could just use the distributive property of ors and ands. I mean, you could think of these ors, if you want to, as multiplication and these things as pluses for starters, because you can really do either one. You could think of one as plus, the other one as times, and vice versa to get the distribution that you want. So you can just convert it like this. It might be kind of handy. And just think of it completely like this. And then just calculate this out. You can FOIL or whatever else you want to do here. You could just put not B is going to be multiplied to everything here. So you're going to end up getting, thinking of FOILing, you can have A squared, so, or A times not B, right? Because I'm just putting not B on everything. So then you have outside would be AC. So I have plus A times C, but then also put a not B because it's on everything. And then I have maybe here I have the inside would be B times A times not B. Okay, plus, and then I can have BC. So B times C times not B. Okay, then I can convert to everything to what it was. So plus was referring to ands. So now these are all ands and. Now all these guys, multiplications now are ors. So this is A or not B. Now A or A is just A. So this is A or not B. This one right here would be A or C or not B. This one would be, well, B or not B is actually everything in the power set because it's B or its complement. So really, and your intersect, so and is kind of like an intersection. So think about these statements as being like sets or subsets in a power set, and think about ands as being like intersections. They even look like intersections, just a little more pointed, but in the symbol, but intersection. And think about these things as being union. That kind of helps a little bit in thinking about this. So think about this as B union not B, or B union its complements. Think of not B as being the complement, and you're unioning it. Well, it's just going to be 1. So, and you union on to A, that's still just everything, right? So, and if you're intersecting something with everything, it doesn't really do anything. So we can just kind of basically ignore this term is all we're saying, just ignore it. And then here, actually, we can ignore that term as well. Ignored. Okay, so we end up getting this statement right here. And this is in conjunctive normal form. So we just successfully able to convert it. Let's put that off to the side. A or not B. And A or C or not B. Great. Okay, now let's look at another method that we could use in order to do this. Well, for one, what we could do is we could just take the complement of, this and write out what's called a truth table. Find, and then find the disjunctive normal form of that, and then take the complement in again, and then we'll actually have conjunctive normal form. So, but we have to proceed in that kind of step. If you just take the complement, of this, you will get a conjunctive normal form. However, won't be the right conjunctive normal form. It'll be the conjunctive normal form of the complement, using this duality thing. De Morgan's laws, thinking of these as intersections as unions. If you take complements, which means the same thing as negating, so if you knot everything off, but instead of the C symbol, if you just put knots on everything, it will turn all these things around and you'll get this, but it won't be the right thing because it'll be the conjunctive normal form of the negation, not of what we want. So to bystep that, what we do is we just take the complement for starters. So just not all of it. And we look at the truth table. Since this is already in disjunctive normal form, we can actually do this in a very nice way. Disjunctive normal form actually tells us a lot about the truth table, because anytime that, because what this tells us is that for instance, if A and B are true, it doesn't matter what C is. If A and B are true, this thing will be true. And so we'll make the whole thing true, because you have true. I mean, think of this as a set even. If A and B are both maybe the full set, maybe merged up to the top thing, like merged to everything, then unioning will just be everything. So the whole thing will be true. So true is kind of like saying that we have everything. So what we could do here in a truth table, we could make a truth table here, A, B, C. And what that means is we think about values. If A and B are both true, doesn't matter what C is, then that'll mean the whole expression is true. So 0, 1. Okay, we got this. Okay. We also know, okay, so we have that for starters. Now, looking at this, we know that if A and C is true, we have the same thing. So we can just get that. Disjunctive normal form actually tells us a lot about the truth table. So 1, 1, 1, then here we can have a 0 or a 1. We already have half of the truth table done just by looking at those two terms. Also, looking at that not B, let's see how we can get the truth, how we can get that one. So not B, that means if not B is true, then the whole thing will be true. Well, that must mean that B is false. So whenever B is false, we're going to have true. Okay, so when B is false, so we've already taken up this option, so we can take another option like that. We're going to get true. We can also take the option, so we have 1, so we have 1, 1, 1, 0. Then we can have 0, 1. We're gonna have true, then we have, let's see, we can have 1, lose my place here. Okay, no, we already used that one, so we have to have a 0. The only other option is 0, 0, I believe, right? Because I used 1. Let's see, hold on. We used 1, 0, and 0, 1. Yeah, so that's it. Okay, so all those will be true. Wow. Okay, so what are we left with? We are left with one other thing here, and what is that? The other thing that we're left with is let's see. We just have one more possibility left. And that possibility would be, let's see, 1, 1, 0, 1, 1, 1. Oh, we already used 1, 1, 1 up here, didn't we? Sure enough. Okay, so we actually have 2 more possibilities. Okay, we already used that possibility up, sorry, on that row. So we have 0, okay, 0, 0, 0, 0, 0. And then we have okay, what aren't we using? So we used up the possibilities with one ones here. We used up let's see, and then if we have 1, okay, so all the possibilities with 1 ones, then 1 zeros. We are still missing one possibility with 1 0. We're missing, or actually we have it 1 0 1 0. We have both possibilities with that. We have both possibilities with 0 0 0 0. So we're missing the possibilities with 0 1. That's what we're missing. 0 1 and 0 1. And we just have a 0 and a 1. So let's see what happens. So when A is false, let's just think about this. A is false. B is true. So A is false, B is true. So A is false, sorry, A is false, B is true, so that's going to be false. Okay, then we think A is false and C is false. Okay, then we have not B. Not B will be false. Notice that we end up just getting false across the line. That's false. Now this one right here, if A is false, that's false, and not and B is true, so not B is false. So that's going to be 0 as well to get those 2 zeros. Now, if we take the complement of these, this, we'll end up getting, so let's take the complement of what we see here. So let's just think of this as being 1, 1, and the rest of these guys being zeros. That means that, so that's like taking the complement of what we just had here, and we can look at this, and this we can actually read off the disjunctive normal form right from this. Where we see a 1, that's going to be kind of like a term in between the ors. So and the complement is going to be simply B, and we're just going to not, so let's see, we have B, and then we're going to have not A, so not A, and B, and not C. Okay, so that's going to be one term. And the other term is going to be not A or B. Well, let's see, not A and B and C. Notice how we can just read that off from that line right there. So not A, B, and C. So that would be right here. We have this, and we're ORing it together. Great. And then we just take the complement. We just reverse everything. So it's A or B, or say A or not B, sorry, or C, and A or not B, or not, is it not C? Not C, if I did that right. Okay, notice, let's compare. This guy is the same as that guy. And this guy right here looks almost the same as this one. It's just that we tacked on an extra or not C. But you can actually, if you look at a truth table and you compare these two, you'll actually notice that the two are actually the same. In fact, even let's just think a minute. What happens if you distribute this as a chunk over across the and to this not C? Let's see what happens. So if we distribute it of the chunk over to the not C, so then the not C will come through, and you say C or not C, we'll actually get a, well, that's going to be everything. It's going to be like unioning and getting everything. And then if you take, everything and union with more things, you'll still have everything. So it'll definitely be true. And that's going to be anded to everything, so it'll just be ignored. So really this wasn't needed, which means that the two forms, both forms are actually correct. And we get conjunctive normal form in two different ways. The first way was just done by distributive property only. And this way was done by a truth table method. So first what we did is we wrote down the truth table, took the complement of the truth table, and whenever we saw one, that gave us a term. The terms were made by just taking, like here, a 0 meant not A, 1 meant B, 0 meant not C, and we put ands in there, and ands, and we had ors, and that represented the complement. Then we just take the complement of that to get back here, and the complement was written in conjunctive normal form. Thanks for watching.